Hello everyone, welcome to the French Math Tailor channel. My name is Antonin. I've been a private tutor for the last 12 years. I've been preparing students from all around the world to different tests such as the math admission test for Oxford, Imperial and Warwick, the STEP, the TMUA for Cambridge, and also SATs in the US. And also, I've been econometrics teacher at LSE for the last 6-7 years now. I'm getting old. And I'm here on YouTube. I already had like a French YouTube channel, and I'm here on YouTube now in English to show to all of the students interested in these different high-end universities what to expect in terms of the harder or the most interesting questions you could be encountering at those tests. And today we'll dive in first with a mass admission test question from a few years back. And yeah, if you like what you see, please subscribe. It will help this channel grow. And tell me in the comments if there are any questions from any country, by the way, that you would like me to correct. It could be like, weird US university questions, some China test that we don't know about. So don't hesitate. I'm happy to cover any interesting math trick that can be useful for the viewers and can be fun for me to solve and to try to convey to you guys. Okay, so let's start with this. For the MAT, what you have to do is quickly detect what are the elements from the A-levels curriculum or whatever country you're in, what are the elements that will be useful. So here, they give you a range for x between minus 90 degrees and 90 degrees. How many values of x are there for which the sum to infinity equals 10x? So you want, I call this S, so you want to solve basically S equal 10x and find out about the solutions. But first, the first trap you shouldn't fall into is just not assume that this converges for every value. First, you detect that this is some geometric progression maybe. You see that you are multiplying every time by the same number. And so you should check for the validity of the convergence. In what domain of x will this converge? Because if you don't do so, you might end up finding solution to the equation where you're actually outside of the range of convergence. So you want to make sure that you have it well understood. So the first thing you should remember is, I'll do some quick recaps like this. If you have any real number q, such as the absolute value is smaller than 1, you can write 1 plus q squared plus q to the power of 3. Like going to infinity equals 1 over 1 minus q. If you're outside of this range, this thing doesn't converge and you cannot write this equation. And so let's check here, okay, if I do if 1 over 10x plays the role of q, then I need to check when this number will abide by the condition. So I do this, if and only if 10x is bigger than 1. And if you remember quickly, you have to have these kinds of graphs in your mind all the time available for thinking. If I do a quick graph to remind you, the tan function looks like this, and you have to know that it's basically a periodic function. So I have this repeating over and over, everywhere. And around 0, I know that this function is odd, therefore I have some symmetry. And you know that between, let me write this down, 90 degrees minus 90 degrees, the function looks like this. When is the tangent equal to 1? Well, it's for the half angle. So the 45 degree angle here, 45 degree here, tangent is worth 1 exactly. And since the function is odd, you know that you're below minus 1 when you go below minus 45 degrees. And so quickly you can say, okay, if and only if tan x bigger than 1 or tan x smaller than minus 1, that's their absolute value for you. And then if and only if x bigger than 45 degrees or x smaller than minus 45 degrees. That's quickly done. You could say, why do we bother? Let's just solve the equation. But you'll see that this will come and bite you if you forget about it. So let's do this. Let's apply then our formula that we know pretty well here and apply it to q equals 1 over 10x. I mean, it's kind of an awkward number, but let's go with it. The first thing I would strongly advise you to do is always to have this one factorized at first. Like this, you have this exact 1 plus formula that appears here, and you can apply it quickly, plus exactly here, etc, etc. Okay, so I have s equals 1 over 10x, and now I recognize that I can just write my formula for 1 over 1 minus q. So here q is just worth 1 over 10x, and this is pretty easy to simplify. That's 1 over, 10x minus 1. Okay, now I've been here, that's the first step. Those mathematician test questions need you to be focused and need you to be pretty fast, I guess. So the first, like the main skill is detection. You need to detect in the question, like the question will trigger, hopefully will trigger the right elements. So you should see this and see, okay, that's a geometric series. The second trigger should be, wait, when does it converge? And then the last trigger would be here, I guess, to even like remember what the tangent function looks like. So the idea is it's not too hard, but the traps will be in how precise you need to be. Like if you know by heart all of your formulas, you see that the question can kind of roll by itself. It's just the attention to detail that will make the difference in between the different candidates. So let's do this. This is pretty straightforward now. The equation is s equal 10x. So if and only if s has been calculated just before, 1 over 10x minus 1 equals 10x. And another piece of advice, it's not bringing anything to the question mathematically speaking, but I like to clarify things. So for the sake of clarity, I like to sometimes write my own variables. Let's replace 10x by another variable. Let's call it big X now. And so if I do this, I have here 1 over x minus 1 equals x, which is basically a polynomial function. When I multiply on each side by x minus 1, I have this happening. Okay, and so then this can be solved. I have this if and only if, well, leads to x1 equals, I can calculate a little delta here, which is minus 1 squared minus 4 minus 1 equals 5, okay? So do this quickly, and I find out that x can take two values to solve for this equation, which is 1 plus and minus. So 1 plus square root of 5 over 2, x2 equals 1 minus square root of 5 over 2. So those are the two values that 10x can take. So I'm like, I feel like maybe the answer of how many answers there will be can maybe lead me to 2. Given then when I have a value for 10x, I have a unique value for x, which is true because 10 is a bijection in between minus 90 and 90. So when you're in between those two values, whatever 10x value you get will give you a unique x value, okay? So that's perfect. But then the idea, I would be tempted here to say, okay, two solutions, move quickly to the next MCQ question. Unfortunately, there is a trick here. Since we have checked that 10x could be either bigger than 1 or had to be smaller than minus 1, I have to check here the ranges and where I stand. So x1, 1 plus square root of 5 over 2 is pretty easy to compare. So it's 1 plus square root of 4, it's bigger than 1 plus square root of 4 over 2, which is equal to 3 over 2, which is, well, clearly bigger than 1. 1 minus square root of 5 over 2, though, is a bit different. So quickly you can check. Square root of 5 minus 1 will be smaller than, well, 3 minus 1 and bigger than 2 minus 1. And so then I will have 1/2 smaller than square root minus 1 over 2 smaller than 2 over 2, 1. And so when I take the opposite, I'll have the same, it's between minus 1 and minus 1/2. There's no way this thing is smaller than minus 1, so I can just destroy it, not keep it, and not get mistaken by this question. And so in the end, I just have x1 equals 1 plus square root of 5 over 2. It's like one unique value of 10x that solve this equation, and then it leads us, since this function is a bijection, to a unique value of x, which is the final answer. I hope this has been helpful. Please comment in the comment section. Tell me if you want to see other questions from the MIT or any other test worldwide. I'll be happy to deliver, and see you next time. Bye-bye.